Hey everybody, up to this point in this course, when we've talked about bond energy, we've always talked about it in terms of a large amount of a substance. What we're going to try to do here is start to build a model that explains how the interactions between individual particles in the substance give rise to the total bond energy. To do that, we need to know how particles will arrange themselves in a substance. Let's start by just thinking about three particles, which we're going to model as these golf balls. What is the most compact configuration we can make with these golf balls? Well, it probably doesn't surprise you that it's just a triangle, like this. Each of the particles in this substance is the same distance from every other particle. It's just the equilibrium distance. Now what happens if we add a fourth particle? Well, your first instinct might be to do something like this, but this turns out not to be the most compact. Instead, we'll place the fourth particle on top of the triangle. Now, each particle is still the equilibrium distance away from every other particle in this configuration. But what about if we try to add a fifth particle? It turns out the only way to do this is by going like this. Notice something has now changed significantly. When we had 3 particles and 4 particles, all of the particles in the substance were the same distance away. However, now that we've added a 5th particle, this is no longer the case. The 2 golf balls in this configuration are not their equilibrium distance apart anymore. Instead, they're about twice the equilibrium distance apart. It turns out that the distance they are apart is not quite twice the equilibrium distance, but we'll use that as an approximation. In a minute, we're going to see how we can expand this to even larger numbers of particles in order to continue to build our model for bond energy.